All right, ladies and gentlemen, this next inequality is a quadratic inequality, but it's a little bit weirder than what we did in the previous one. So let me kind of help you with this. I'm going to take the way it was originally written, okay? And I don't actually like the way it was written. It's in the wrong order. There's just a lot wrong with this. So I'm going to start rewriting it. I'm going to write this as the opposite of x squared plus 18x minus 81 is less than 0. Okay? Now all I did there, nothing miraculous. I just put it in the correct order. Leading term, opposite of x squared, the 18x in the middle, and the minus 81. Now the next thing I don't like, when I'm writing an inequality and I'm putting the time into rewriting it, I want my leading coefficient to be positive, so I'm going to multiply through by -1. When I do, this is going to make this x squared. This is going to be a minus 18x, right? Everything's getting multiplied by -1. This is going to become a positive 81. But now if you're following what I'm doing, you just multiplied an inequality by a negative, so the inequality sign switches. That's a very important thing to notice. And of course 0 times -1 is 0. Alright? So what I'm really doing is I'm not liking the way the original problem was written, so I'm rewriting it. I put it in the correct order and then I multiplied through by -1, which changed the sign. Now, this expression factors. This is a perfect square trinomial. In fact, it factors as x minus 9 quantity squared. And we want to know where that's greater than 0. Okay? So don't pay attention to the original form of the problem. Pay attention to what I now have right here. Or here. Okay? Now, when I look at this parabola, it only has one 0, right? And that would be the number 9. So, if I were to draw this graph, I'm going to put a dot right here on the number 9. That is my 0. It's the only 0. This graph opens up, and again, I don't care how wide. I don't care how wide or thin right now. All I care about is the graph is opening up. Okay, I'm not drawing this to like a perfect scale. What I'm interested in at this point is what the zeros are, and there's one 0, namely 9, and I'm interested that the graph opens up. I want to know where this function is greater than 0. So I'm going to shade in anything that's in quadrants 1 or 2. That's where y is always greater than 0. Well, lo and behold, I shade in this branch, I shade in this branch. So it almost looks like we've shaded in everything, okay? That everything, that all x's, meaning all real numbers, are included in my answer. But that's not the case. What did I not shade in? What is not included in my answer? Well, the number 9 is not included. And the reason the number 9 is not included, this did not say greater than or equal to 0. So you have to be very careful about that. So almost everything is part of your answer here. Almost every real number is part of your answer. The only one that's not is 9. So again, if we scan from left to right, we're going to get our answers. If I start scanning from left to right, I come up with this first branch, which is included, and that would be -infinity to 9. Again, put a paren because 9 is not included. In fact, I hop over the 9, union, and when I scan the next branch, which is part of my answer, that would be 9 to infinity. And of course with a paren, not a bracket. So basically what we've done here is our answer to this problem is all real numbers except 9. So no to that, no to that, no to that, and yes to choice C. and we're done.